Hello, my name is Paul Bevan from Siemens Digital Industry Software, and today I'd like to talk to you about NX Implicit Modeling, a brand new application in the December 2020 release of NX. As you will see, NX Implicit Modeling has a dedicated task environment for creating and editing implicit geometry, whether that's the creation of equation-driven structures or, when needed, the performing of robust modeling operations on complex designs. In the additive design space, there's been a shift from the traditional rod and ball structures to these triply periodic minimal surface structures, such as gyroid and Swartz. And this is mainly because of the inherent properties they possess. These properties are very interesting to the additive community. The structures are self-supporting, which is a big benefit when it comes to the 3D printing process. It means that there's no need for any extra support structures. Their mechanical properties are of interest too. If we take a look at the example of a gyroid structure, it's excellent in energy absorption. And from a thermodynamic perspective, they're also very good at dissipating heat. So their use in heat exchangers is becoming more popular. Taking all this into consideration with the fact that these structures are also lightweight, makes them ideal for numerous design applications. So let's take a look at how we create one inside NX. So in my NX session, you can see I have a running shoe assembly. And the first thing I'm going to do is to make the sole translucent so we can see inside it, because this is where we're going to create our gyroid structure. To make it easier to see exactly what's going on, I'm going to open this sole in a separate window, and then using the multiple display window capabilities in NX, have the sole and the final assembly side by side. So now that I've got my NX session set up the way that I want it, let's start by opening up the implicit modeling environment. In the task environment, you'll notice that we have 5 predefined implicit structures, together with a general equation function which allows users to define their own. You'll also notice some other standard modeling capabilities inside the ribbon interface. As previously mentioned, I'm going to add a gyroid structure to the running shoe sole. This will make the shoe lighter, but also help dissipate any impact forces during running. So let's add the gyroid structure. But before that, I'm going to modify the resolution of the resultant body. Now, when I activate the gyroid command, you can see the various parameters that I can change, whether it's a uniform or non-uniform cube, the size of the edge length, the orientation, and also the porosity, together with the thickness of the structure itself. I'm happy with the current values, so all I need to do now is to select the sole geometry, and you see a preview of the gyroid structure. I can make changes to this structure before I apply it. Here I'm just going to modify the porosity. I increase it or decrease it depending on the requirements. So let's take a look at the resultant gyroid structure. So let's take a look at the resultant geometry. NX is calculating the gyroid structure and bringing it into the sole component. Notice the structure appears in both the individual part file and also the shoe assembly. We complete the command, and if we temporarily hide the sole geometry, we can use dynamic sectioning to take a better look at the makeup of the structure. Now that I have my gyroid structure, I can complete the design of the sole. But before that, I'm going to switch off the dynamic sectioning. Next, I'm going to bring back my original sole geometry, and I'll do this via the Part Navigator. Notice that within the Part Navigator, that gyroid structure is now a feature in its own right that I could go back and edit if necessary. But for now, I'm going to bring back my original data and hide the implicit model. The next stage in the process is to create a void into which I can adapt my gyroid structure. And to do this, I'm going to create another implicit feature. I'm going to import the original solid body. And what that does is that it creates me a mesh body, a convergent body that I can use. For those of you unfamiliar with convergent modeling technology in NX, it's a really powerful capability that enables me to work effectively with both precise and mesh geometry within the same part file. This greater flexibility in the way that I can design reduces significantly the time taken to complete designs where a combination of precise geometry and mesh geometry is required. To create the void I need, I'm going to use another command within the implicit modeling environment. I'm going to shell the body that I've just imported. To see the result of my shell command, I'm going to reactivate my dynamic section. Notice that as I drag the section around, you can see we have a constant wall thickness on this convergent mesh body, something that would be very difficult to do without the power of NX Implicit Modeling. So I have the void that I need to adapt my gyroid structure, and to complete the process I'm going to extract the internal face, because I'm going to use this to trim the gyroid structure. And this again is where the power of convergent modeling comes into its own. I bring back my gyroid structure and then just use the standard NX trim command to make the adjustment. You can see that we've added further parametric features into the part navigator, and I can remove or hide the extracted face to see the result of the trim. So there are two more tasks to undertake to complete the design. The first thing is to create the void in our original geometry. So I bring back my extracted face, and I also bring back my original sole data. Now again, with the power of convergent modeling technology, I can trim my original body with my extracted face, which was mesh geometry. Again, this illustrates the power of being able to work with both mesh and precise geometry within the one model. So that's the trim complete. I'll hide the extracted face, and now we can see the result using the dynamic section again. Notice the void has been created in our original sole geometry. The final task is to combine the adapted gyroid structure and the original sole geometry. And to do this, again, we'll use the power of synchronous modeling technology, which allows us now to unite precise and mesh geometry together. So that's our design complete. Again, we can visualize what we've done using the dynamic section. Again, as we just move the section through the part, we can rotate it and look at it from a different orientation. Again, slice it that way. And finally, let's take a look from the top. So again, we can rotate our plane and then again just drag the section just to get a good visual of what we've actually achieved. So that's an overview of the new implicit modeling capabilities in the latest release of NX, where you can create equation-driven structures and perform robust modeling operations on complex designs. When you combine this capability with convergent modeling technology, you get an extremely powerful and versatile mixed modeling environment that make these sort of design tasks easy. I'd like to thank you for your time and attention.